Topic 10, application of differentiation, will also be asked in section A and section B. For section A, it will just ask you about the relative extremum, which is the maximum and the minimum points of a function, and you have to test it using the second derivative test or the first derivative test. So the working are all the same for every question of asking the extremum point. So look at the set 1 from section A, question 3. It says determine the relative maximum and the relative minimum points of a function fx equals to x cubed plus 3x squared minus 24x plus 20 by using the second derivative test. So what you need to do first is to differentiate to get your f prime x, and we will equate f prime x equals to 0 to get your values of x. And since it asks you for the points, you have x already, you have to find your y. And then your critical points here are negative 400 and 2, negative 8. But you have to determine the nature of this point, whether it is maximum or minimum. So we are going to use the second derivative test as the question asks you to do. And when we substitute x equals to negative 4, we get the second derivative to be minimum, to be negative, which is the maximum point. And when we substitute x equals to 2, you get the positive value, which shows that the nature of the points is minimum. So that is how you show or determine the relative maximum and the minimum point. Similar with set 2, first you need to differentiate, equate with 0, finding the values of x. And when you find the value of x, you can find the value of y. So here there are 3 points that you have for your critical points, which is 0, 14, negative 2, negative 18, and also 2, negative 18. So using the second derivative test again, we check whether it is maximum or minimum. Since for x equals to 0, it gives a negative value, so it's a maximum point. For x equals to negative 2, your second derivative is positive, meaning that it's a minimum point. And when x equals to 2, your second derivative is positive again, which shows it's a minimum point. So there will be 1 maximum point and 2 minimum points in your fx here. Lastly, for section A, set 3, it gives you the function for the curve y equals to x cubed plus bx squared plus cx. And it says it has a turning point at 1, 5. So what we need to do here is, first, you have to find the values of b and c. So how to find the values of b and c here? We just substitute. When x equals to 1 and y equals to 5, we get one equation. And also, we can differentiate your original function. And then substituting x equals to 1 and y equals to 5, dy dx equals to 0, you will get the second function. So since you have two unknown, which is b and c, you can definitely find them using simultaneous equation. Why we substitute dy dx equals to 0? Because it says it has a turning point at 1, 5. So that's why you can substitute dy dx equals to 0 and x equals to 1 inside your differentiation here. And then it asks whether the stationary point 1, 5 is minimum or maximum. So again, using the second derivative test, we can check your second derivative test at x equals to 1. We get a value less than 0, which shows 1, 5 here is a maximum point. Section B will ask about the rate of change and the optimization problem. So the most important thing about the question is you know what type of shapes you are dealing with, because you have to know the volume, the volume and also the surface area for that particular shape that you are dealing with. So for example, question set 1, section B question 7, it says we have a water tank has the shape of inverted circular cone. So we are dealing with a cone here. Make sure you know what is the formula for the volume of a cone. And it says it has a base radius of 3 meters and height of 5 meters. The water is being pumped into the tank at the rate of 2 meter cube per minute. So 2 meter cube per minute is obviously it's dV over dt. And it says find the rate of change in water level, meaning that it asks you for dH over dt when the water is 3 meters deep, when H equals to 3. So these are the information given by the question. These are the shape that we are dealing with. So we started off with the formula for volume, but we cannot differentiate V here because it involves two variables R and H. And as I said, R and H for a cone is not a constant, unlike cylinder. So we have to find the connection or the relation between R and H. So R and H here, we can use the rate theory. So if R rate with H is similar with 3 rate with 5, so R and H is connected with R equals to 3 over 5 H. Then we get V in terms of H only. Then you can differentiate V to get dV over dH. Substitute inside your chain rule to get your dH over dt. And this is the answer for the next question. Air is pumped into a spherical balloon at the rate of 12 pi centimeter cube per second. Find the rate of increase of the surface area when its radius is 6 centimeters. As I said, we have to know what is the shape that we are dealing with. Here we are dealing with a sphere, so that is why we have to know the volume of a sphere and also the surface area of a sphere to get your answer. For set 2, we are dealing with a right inverted cone again. And it says the semi-vertical angle is 45 degrees. So you have to know what is the semi-vertical angle here. And why it's given to you the semi-vertical angle. Because again, you want to see the relation between R and H. Because you cannot differentiate V unless it has only one variable inside it. Okay, and it asks for the depth of salt water after 45 seconds. And I already explained this in the tutorial. If 1 second refers to 3 pi, so 45 seconds you need 135 pi centimeter cube. And that is your volume, but we don't want volume, we want H. So we change back using the volume formula to get your H. And the second question, it asks for the rate of change of its depth at the instant. So using your chain rule, you will get your answer when H is equal to 7.3986, which is the one that we found in the first question. Alright, for set 3, section B, question 7a, again we are dealing with a cone. So first, we have to know what is the relation between R and H, because we cannot differentiate V unless it's in one single variable. So now we can use this one, the change rule formula, to get your value of dH over dt when H equals to 3. And last one, we are dealing with a cylinder. The volume of cylinder is 128 pi. And its total area is A equals to 2 pi r squared plus 1/128 over r. So what we are going to do is just use the formula for the surface area of a cylinder, and then calculate the minimum value of A. So again, we have to differentiate, equate with 0, and finding the value of R, and check the value of A again using the R equals to 4 to get your value of A equals to 96 pi centimeter squared. And that is all for topic 10.